All right, we are on air and we are live. So just be on your best behavior.
No.
Officially, that was April who said that. So just for the record.
I said shush.
All right.
Give them everything. Last name, social security number. It's Friday.
Well, the Nigerians would like your social security number or
Yeah, right.
banking account number, please.
Yes, I can be the next princess of Uganda.
Well, you'd make a good princess, but I don't think you want that one. Morning, Ken.
So I put a file and a document in the file, and I shared it, but I only see it on the server that has the storage for it. I don't see any other.
Is file and printer sharing going on your machine?
It should be. I'll check again. I believe it is. I'll check.
By default, it should be, right?
Yeah, because I found those. I found where that said the with the share you can.
I'm going to put the tip jar up here later. So.
Let me find it.
All right.
See, there it is. This is the share right here. And that's the folder in the share. Now, if I go into I don't know. This is what
All right, there we are. Since I'm doing a screen share rather than an actual picture of the slides, we can turn the light off if you want. That won't wash out the picture. Somebody hit the light. Thank you, Louis. All right, good morning, everyone.
Good morning.
Clap 5 times in hexadecimal and twice in binary if you can somewhat hear what I'm saying at the front. All right, what we're going to look at today, Module 8, is about Federation services. You can walk into, especially if you go into a large environment, you can walk into an environment where we're working maybe with other external partners, maybe we've done a merger or acquisition. We have different organizations that want to work together. Federation services can help with that. We're going to see a couple scenarios where we might want to use this. So let's have an overview of what Federation service is, what's involved in deploying that in our environment, implementing this for a single organization, deploying this in a business-to-business scenario, extending this to external clients. So there's a lot to see in here. This is a big subject area. And definitely you'll see some questions on the exam about this subject. So let's start with an overview about Federation services. Where did this come from? It's all about identities and claims. So we'll talk about what is an identity federation, what is a claim-based identity, how does that work? We'll need to talk a little bit about what is a web service, so we understand that, and how does Federation services play into this? And what does it give us, including a very nice feature of stuff like single sign-on, SSO. Single sign-on makes the user's experience very nice and pleasant. They don't constantly get asked for another username and password, a different username and password to go to, and so on. So we'll talk about doing that, including a single organization, business-to-business, online services and stuff. And if you were using this before, right? Everybody had used this several times before in the past, before they started this course, correct? No, okay. We'll tell you about what's new in 2012 R2. All right, so let's get into what is identity federation. So it's about authentication, all right? Proving who you are. What's your identity? Showing ID, right? How do we normally do this in a larger organization that has Active Directory? We log into Active Directory. What happens during that process? We contact a Cabero server, correct? All right. We supply a username and password normally. based upon that username and password being valid, we're given a token. We can then go access resources. We might be authorized to do certain things depending upon the token that I'm given. So there's a way for the system, like Active Directory, to prove my identity, to make sure that I am that person I claim to be. And then based upon what I supply to that authentication service, it can then authorize me to do various stuff. But I want to enable this now across organizations or platforms that a single organization may run. For example, a Unix-based or Sun Spark-based system and my Windows-based system. To make identity federation work requires some type of trust relationship between those organizations. Right? I'm trusting you to identify somebody. And if you say he's okay, then I'm going to allow him access to resources in my organization. All right? That's very, very powerful, but very scary, right, for some organizations. I want to know that when you authenticate somebody and prove their identity, you're doing it the right way, that you are being careful about it, because I'm going to trust you. So we don't just set this up with everybody who just comes along. Hey, your company looks cool. Yeah, you want to do a federation service? No. All right, but CityTech is working very, very closely with Microsoft on this project itself, along with the Tech Talent Pipeline. They may want to federate. They may want to do something in this collaborative project. And, CityTech will trust Microsoft. Microsoft may trust CityTech. Great. All right, they're large organizations. They're well-known. They're public and so on. They could form that kind of trust relationship. Now, what's really important is that the organizations do retain control over who accesses resources. So I'm in control of what files that you can get, what web servers you can go to in my organization, what printers you can use. I'm still in control of all that, all right? Because I want to be in control, right? I'm responsible. I want to be in control of stuff in my organization. Enables also organizations to retain control of their user and group accounts. Give me 1 second here. Hi, Monica. They're watching a movie in the other room. Let's go there. All right. Anyway, so organizations retain control of their user and group accounts, right? I don't have to add users and groups from somebody else's Active Directory environment to my groups in my Active Directory environment. That's pretty nifty. Again, I'm retaining control. When it comes to security, I want a lot of control. Good to be a control freak there, right? You can be paranoid. Not a bad thing in the security world. Don't trust anyone. Or, I don't forget some politician, trust but verify. Reagan? Okay. All right. Now, we've seen a little bit about claims. We've heard about claims already. Where did we hear about claims, Anthony?
Security protocol.
DAC, right? Dynamic Access Control. One of the places where we had claims. Right? A claim is information about a user or a device, such as that he belongs to this group, or this device has this operating system, or it's in this location, or it's managed by a certain person. The information is provided by the user's identity provider. Who's an identity provider that we've been working with all along? Active Directory. Does it have to be Active Directory?
No.
Well, no, it doesn't. It could be something completely different in a Unix environment. Completely a different system, all right? But somebody somewhere has to provide information about the user and the claims being made about that user. That's called an identity provider. We want the person or the object or the system that's working as the identity provider, that when they supply that claims, that the resource accepts those claims. Right? That's called the application provider. Somebody providing that application, which could be like printing service. Right? So some identity provider is out there making claims about a user. When the user goes and tries to access or you run that application, like print to that printer, that application provider has to accept that claim, which is great. How do we do this? Security tokens. So on one side here, on the left-hand side, we see the identity provider. There's some type of security token service, and it makes a security token. This is a claim being made. All right. That's an outgoing claim in this case. It goes through the system. That's the whole cloud thing. That's what that cloud means in this slide. And then on the application provider, it accepts this claim. It says, okay, you've made this claim. Who are you? What is it? Are you in the right group? Are you using the right username? Are you managed by a certain group? Do you have a certain manager? Are you in a certain location? Whatever it is, to allow access to that particular application. Seems almost easy, almost, right? Gets complicated though. This is not a simple system. There's a lot going on in here, and we'll see in the next couple of slides. In order to understand some of what's going on, we need a little bit of an idea about what is a web service. It's not a Microsoft thing. But what they wanted to do was have a set of standards. In the computer world, we love standards and protocols and stuff like that. Really what they are is standards, which are basically a group of protocols that we have to build applications, web-based applications, and have other applications use those. For example, I can build a website that connects to the Weather Channel, which is running a web service to tell me, based upon my location, the current temperature, or the 5-day forecast, or whatever. Or I can connect to the NBA's web service that gives me the current scores or standings in a particular division. I don't know nothing about the basketball. I know it's a game. I know it's got a basketball on a hoop and stuff like that. I work next door in Secaucus next to the NBA, actually. So you see their vans there a lot, the big buses and that type of stuff. And some of them stop in the bagel store that I get my breakfast in the morning. I have no idea who these people are. There's a lot of pictures on the wall, and also the Giants and Jets stop in there a lot too. So if you want to try get a chance to meet some of them, go hang out in Secaucus. If you ever visit my neck of the woods, you can please come and see me. Wow, yeah. But in the building where the NBA is, ETech Training actually has a 2 classrooms in that building, the same building, but they have a whole floor in that building. So great, okay. So web services are a standard built around a group of protocols. The core of it is the XML, all right? A way for systems to exchange data in a very generic format. It stands for the Extensible Markup Language. It uses something called tags inside of a basic text document. And in there, we encode the data. We say this is a customer has an attribute like an address and that type of stuff. Great. So when a web service wants to talk to another web service, it's going to exchange data and send data through an XML file. The format of that XML is going to be defined by something called SOAP. Not shampoo, SOAP. Which stands for Simple Object Access Protocol. You go on the web and you go get quick definitions of these things if you want. So the XML, the way we're transmitting the data, is defined and formatted according to SOAP. What makes a valid SOAP message is defined by WSDL, or the Web Services Description Language. Don't you love this? All right. The web services are described by the Universal Description, Discovery, and Integration, or UDDI. if you're a web developer, if you're building web services, you'll be very familiar with this stuff. That's your little world. Now, we're not doing that. We're not in a web development course. There's a lot of resources. If you're interested in that, out there on the web, great. But that's not what we're doing here. But we want to understand when I talk and I say, oh, it's a web service. I don't want people shaking their head going, what is a web service? What does that do? Basically, it's these standards here for transmitting messages, for one web application to talk to another application, because that will happen here in federated services. All right, so we took this little side trip down here just to get some definition so we're clear about what a web service is. And it's a very high-level overview. You can spend 3 months learning how to build and do all that stuff in and of itself. All right. There's a language or protocol for exchanging identity claims, an open protocol, SAML, or the Security Association Markup Language. Don't you love acronyms? You better love acronyms if you're going to be in this field. All right. Just what? In about 10 minutes I've been doing this presentation, you got like 6 new acronyms? So eventually, yeah, we will. The secret language, all right? So, well, the doctors have their Latin or Greek or whatever that they're talking in. Well, computer people have their acronym language, all right? Great. It's an XML, and if you open it up, that's what it is. It's a formatted XML that allows secure web domains to exchange user authentication and authorization data using SAML. An online service provider can contact a separate identity provider. All right? So I can set up a website that's locked to people that supply an identity to Microsoft's login live ID system. All right, which is kind of cool. So that's a separate identity provider which will authenticate the users for me. And then I can give them access to my content. This is all stuff from Wikipedia. That's where I copied and pasted the definition from.
So XAML, is that like encrypted XML? Is that how it provides the authentication?
No, it's not necessarily encrypted, no. Just a format for the XML data that's being sent back and forth. All right, so we get into the real main part of this presentation, which is federation services. It's a product Microsoft has created for identity management, claims-based authentication. A lot of great features. One great feature is single sign-on. If we're in today's modern environments, there may be several web-based applications that our users are going to want to use. For example, there might be a really cool web-based app that people use for human resources. To go choose maybe their medical plan, sign up for the dental plan or eyeglass prescription plan. They want to sign up for various training, maybe in human resources. All right. Payroll, accounting might be there. All right. Your procurement to get equipment or something like that, there might be applications to do that. Mm-hmm. So customer relationship management and so on. So all these different web apps that my company is running on, they're great apps, but every time they go to one of these websites, do they have to supply another username and password? No, that's really an annoyance to my end users. You really want them to just have a single sign-on. So we get that single sign-in feature. We got interoperability with web services on multiple platforms. That HR app could be running on a Unix machine. It does not have to be built on Windows. That machine doesn't know anything about Active Directory. Support for many clients, web browsers, mobile devices, other applications. Extensibility to support customized claims from third-party apps. Delegation of account management to the user's organization. It integrates with DAC, Dynamic Access Control. And we have our favorite Windows PowerShell commandlets to help us administrate that. Okay. So let's take a simple single organization. There's just one organization. All right. On one side, you see we have a corporate network. There's a domain controller in there. And we've set up a federation server. There's a federation service proxy and a web server out on my perimeter network, or screen subnet, or whatever you want to call it, DMZ. There'd be firewalls, obviously, between my perimeter and the corporate network, and firewalls between the perimeter network and my external clients that are out there on the internet. Okay. So the external client's trying to get to my web server. All right. That web server is protected. You need a username, you need an identity that has to be validated before you can access that web content. Maybe it's that HR app I was talking about before. So the web server says, well, who are you? In order to get access, I'm going to need to prove or provide a security token with my claim in it. So it contacts the proxy service for federation server. That's out there on the perimeter network. And that should not be domain joined. The proxy, and of course my stupid thing. Hopefully it worked now. All right. So the federation service proxy then passes through the interior firewall, contacts the federation server. Says, well, this external client is looking to access the web server and needs a claim. Come on, man. Guess I'm not going to be able to use this constant. So the federation server contacts the domain controller to get information about the claim. That's the provider of the information provider. Active Directory does what it needs to do to generate that claim, sends it back to the federation server, which will send it all the way through the proxy back to the client. The client will now be able to access the web server. All that back and forth. Happens very, very quickly. Pretty nice. What if it's in a business-to-business? More complicated. All right, here we're not on the internet. The client is actually internal to Trey Research. So you see is on the left side. In Trey Research, they have set up federation services. They built a federation server. They have Active Directory installed. Things good. And then they decided to build a trust with a datum. A datum has a federation server on their side, and they're the ones doing the trusting because they're running the resource, the web server that my internal client wants to get to. So what do I want to do? I don't really want on a datum's web server to create a user account and group or something for the internal client at Trey Research. I don't want to manage that. Trey Research manages the users and groups and all that stuff. So the internal client, hi, web server, I'd like to get your content. Web server says, whoa, who are you? The internal client computer is sent to the federation server on a datum, the resource federation server. Because the web server says, well, in order to get to me, that federation server has to say you're okay. Tells the internal client, oh, you have to do what you got to do to get the proper identity. So it contacts Trey's Research account federation server because it needs a security ticket. That will contact Active Directory, validate that user. That's why I like to write password and that type of stuff. You?
Both sides have to have federation services installed to establish.
Yes. Yes. All right. So yes, both sides need federation service. So the account federation server contacts Active Directory, verifies a user account, builds the claim ticket, that security ticket, passes it back to the computer, which then sends it back to the federation server at a datum. All right, lots of round trips here. Federation services, okay, now that I've got the proper claim that's been made by the Active Directory server and the account federation server in Trade Research, I can supply you the correct credentials to get onto the web server, in which I do now. Send to the web server and get access. That's 11 steps, yes. Yes. For that user to get to that web server. Carl.
Why didn't the two federation servers just?
Well, they kind of are, but through the client, I guess. It's just, they're not going to, they may not, yeah, they might not be in the same network. They're separated, and I don't want really that traffic probably to go over maybe the internet or whatever. That's just the way it's set up. Yeah, so it's a lot. Yeah, my federation server also may need to talk to many other federation servers depending upon who I am and that type of stuff as well.
But would it always talk, it would like talk through the client?
Yeah.
Okay.
Credentials have to come through the client and that type of stuff. Yep. Online services could be used. It's very similar to what we had just seen. The internal client computer, there's a web server running Outlook web app, and Microsoft Online Services Federation server run by Microsoft Exchange Online. You set up a trust, that federation server may have hundreds of people, hundreds of other systems set up with these types of trusts. So the internal client computer tries to get the Outlook web app, sends the request back, contacts the federation server contacts the client. Client will then go to the account federation server through Active Directory back to the federation server at Microsoft Exchange Online, which will then issue the appropriate resource token and get to the web app. Same exact thing, except run by more of a third party than whatever. So these online services, Microsoft has one. Other people could set them up as well. So single, and this is all about single sign-on. This is just so I don't have to supply another username and password for a Microsoft Outlook web app. So users not managing 2 or 3 passwords. Imagine if they had dozens of web apps they had to go to, changing passwords every 30, 45 days. It'd be problematic, and the user is going to get frustrated. Plus, it slows them down from their work. All right. New in 2012 R2. If you were frustrated before when you were installing because it required IIS 8.5, it's no longer required. You can now install on domain controllers. I don't do this. That's just me. Better authentication now. We can apply policies within specific scopes. We can use multi-factor authentication, like smart cards, one-time use passwords, and stuff like that. There have been some new device claims added, mostly for device and certificate-related claims. The web application proxy. There used to be something called the Federation Services proxy. It's now just called the web application proxy. Secure remote access to web-based applications. All right, great. Let's look at deploying this. The components, the requirements, including requirements for certificates in the PKI infrastructure, and the server rules for Federation Server. This is an important slide. Let's just go through this. We see that we have, in this case, it's a business-to-business scenario. In the partner network, there's some type of attribute store. Again, they're using Active Directory. They don't have to, but they say we're using it for this example. The Federation server in the partner's network needs to create an object called a claims provider trust. In other words, we're telling the Federation server in the partner network, hey, you can trust claims provided by this Active Directory environment. We're creating a claims provider trust between that Federation server and the Federation server in my internal network. That's the dotted red line. So I'm telling the Federation service and my internal network, hey, you can trust claims provided by that other Federation server. This may, however, go through the web application proxy, Federation service proxy, which is the old name. My Federation server internally also has a claims provider trust with my Active Directory environment as well. Somewhere also in my environment, I have a resource that I want to make available both internally and to people in the partner network. That's that application server. All right. So there's a trust that's going to be built between my Federation server and that application server. So my application server is basically being told, hey, if the claim is provided by this Federation server, you can allow access. You can accept that claim. You notice the word trust is used a lot. That's what this is all about. Who trusts who? My application server trusts my Federation server, which trusts the other Federation server in the partner network, which trusts the Active Directory attribute store.
It's like the Secret Service.
Yeah. But there's a wide variety of things. Anthony, question?
Yeah, it's kind of complicated, but it's very analogous to social logins that happen on the internet between Facebook, Google Plus,
You're right. You've ever done that, right? You've gone to some, even Medium uses that, right?
Right.
Well, yeah, where you do
With your Facebook account.
right, exactly. So who's the authenticator? Facebook.
Is the authenticator.
Right? And when
Yeah.
Facebook says you're okay and that you're this person, it makes a claim about your identity, and Medium uses that claim to say that, all right, I trust Facebook has verified your identity.
Wow. And I think the reason there's so many back and forths is because you have to go back to the user and they have to input username and password. So they have to establish the federation between the provider, number one, and the user has to do something that has to go.
But in single sign-on, they don't even have to do that. It's all going back to their machine, because their machine, when you log into your machine, it holds a copy of your username and password. What you probably don't realize is that several times during the day, if you're using your machine in an Active Directory environment, it's being asked for your username and password. It's just being sent silently in the background.
Okay.
All right.
Oh, so that's what this is.
So, but yeah, if you've seen this online, it's a good example of when you see sites where you have to log in with Google account or something like that.
Even
Able?
even with that kind of feature, there's still the potential for a lot of latency.
Yeah, you're going to get latency,
Back and forth.
right? But it reduces the complexity and really isolates these environments from each other, so that we pay the cost in latency, but we get more control and more security.
Yeah.
But even that latency is, remember, this is not continuous. So it's a little bit of a latency when I first log on, but then I start using the web app and things are going back and forth, and we're okay after that point. But yeah, it does introduce latency. It does increase network traffic. There is some stuff going back and forth. That's how this works. All right, so almost everything, there's some type of trade-off. Cost, complexity, traffic, whatever. Okay. Requirements for a successful deployment. All right, there's a lot of infrastructure that needs to be set up properly, including TCP/IP connectivity. Should be good, solid, and strong. Obviously, Active Directory. All right, if you have a problem with Active Directory, this is an issue. Or other attribute stores. If you're using other attribute stores, you might have a web-based attribute store. You may use a public one like Facebook. I would never use Facebook for an internal company log on, but that's a whole other story. You need DNS running properly, obviously, and compatible operating systems that support this, which is most new stuff, so we're in the clear on that. And in Server 2012 R2, installation changes is again, IIS is not required, but there is no standalone server option anymore for Federation services. It will be connected to Active Directory. There are several certificates used by Federation services. A service communication certificate, so the Federation servers can talk to each other, very important. Token signing certificates, when Federation server issues a security token, it should be signed so we can verify that it did come from a valid Federation server. And token decryption certificates, so I can decrypt the tokens as appropriate. All right. When choosing certificates, make sure that the service communication certificate is trusted by all Federation partners and clients. You might even want to get a third party in that case, and that's fine. If you use an internal CA, then the users must have access to a certificate revocation information. The CRL, remember that from our talk about certificate services? That has to be verifiable by the client. Roles. A claims provider, Federation server, authenticates internal users and issues signed tokens, that's why we need those certificates, containing the claims about the user. They belong to this group, they're managed by so-and-so, they work in this office, whatever. Okay. Relaying party Federation server consumes tokens from the claims provider, but issues tokens for application access. They're issuing a token to get to that web service, to get to that website, to get to that file, folder, whatever. A proxy server is deployed in a perimeter network, preventing people out on the internet or even in the perimeter network from directly contacting your Federation server running inside your internal organization. All right, we don't want them, this is kind of a security thing. We don't really want my Federation server accessible directly through the internet. You?
That's different from a web proxy server? Federation server proxy?
Yes, that's different than the,
I thought like the web proxy server replaced the Federation.
no, there's a, that's, I think it's something else. Hold on. At least they've made a Federation service proxy and Federation server proxy. The service proxy, I think, was replaced with the web application proxy. I think so.
Well, what exactly is the Federation's proxy doing different from the web application?
Let me make sure that they're not the same and Microsoft hasn't switched these words around. We'll get back to that. They may be talking about the web server. The web server is supposed to allow access to the web applications itself. From what I understand, the web server or the Federation server proxy is about controlling access to the internal proxy server, or I'm sorry, the internal Federation server. So it's just a gateway, if you will, to the Federation system. It's not a party Federation server issuing tokens for access to a web server. Let me get a better explanation to make it.
It's tied to the internal Federation server.
Right, it's just a way from, right. So instead of giving people direct access to my internal Federation server, I'm making them pass through this first. So I can, it's like a firewall thing almost. That's the idea. And let me clarify that, make sure that some words didn't get screwed up and everything's proper terminology. I have a feeling that somewhere on one of these slides there's a typo possibly. But we'll come back to that. Okay. Implementing for a single organization. We'll talk about claims, claim rules, claim provider trust, relaying party trust, authentication policies, and multi-factor authentication. lot to talk about here. First is to make sure we understand what Federation Service thinks of as a claim. Information about users from some type of claims provider. That's going to be passed to that relying party. Federation Service has a bunch of built-in claims you can just use right out of the box, but you can create custom claims if you want. Things like department and that type of stuff are already in there, but if you want to create your own, like security levels, high security level, medium security, you could do that as well. Requires that each claim have a unique URI, Uniform Resource Identifier, sort of like a URL. Right? What is a URL? It's like a web address, right? Everybody's got a unique one. So each claim has basically a unique identification. Like a similar idea is SPN, service principal name, service provider name. All right, so the claims are going to come from where? Some type of attribute store, like Active Directory, can be calculated based upon retrieved values. So if the user belongs to this department, I look in Active Directory, find the user belongs to this department, is a member of this group, and works at this particular location, I can make a claim that the user has a high level of security access. In other words, I can create a claim right on the fly that doesn't actually exist in the attribute store. This is a little bit different, right? Normally we think, okay, the information has to be in Active Directory. Not necessarily. I could do a calculation. I could add those things up and figure those things out. I might also need to transform a claim into an alternate value. Right? Because their system bases security on your security level is 1, 2, 3, 4, or 5. My security level is high, medium, and low. How does that transform? How do we share those claims? My system, when I ask, well, Carl, what's your security claim? He says 5. I say, well, that's not low, medium, or high. That's an invalid answer. The Federation server can transform that based upon a rule. So if the other provider says that your security level is 4 or 5, I will change that to high. If the other one says that your security level is 2 or 3, I'll change that to medium. If it says it's a 1, I'll change it to low. Nothing has to change in their system. Nothing has to change in my system. The Federation service can make these claims and transform them dynamically. Carl.
So, for example, let's say in Active Directory, it has my address says Brooklyn, New York, whatever.
Okay.
And I'm trying to access a web app that requires content.
Right.
So we can calculate based on my address the content to give. To the web
Right. You say he's in North America. Exactly.
where that content isn't in Active Directory.
At all. Right. Exactly. So it's very, very flexible. You can create these custom rules to modify and calculate claims and transform them from one value to another. So it's very flexible. You can spend a lot of time doing this, and this is a specialty within the computer field. Some people might specialize in what they call identity management. Okay. Claim rules define how claims are sent and consumed by these servers. All right? There are a bunch of default claim rules, templates, and there's a whole syntax for creating custom ones. All right? And trust me, whenever I had to do this, I've always had to look them up. I don't remember the syntax. Again, it's like learning another language. I trying to, PowerShell, old command line tools that I know, and that type of stuff. For me to pick up this stuff, I just use references. Google's your friend. Okay?
What's an example of a situation that would require you to create a custom one?
Because I wanted to do one of the things we were just talking about. Let's say transform an alternate value. I need to transfer your security levels of 1, 2, and 3 to high, medium, and low. So I create a custom rule that says if this is equal to this, do this, and if it's not, then do something else, and so on. So it's like a little bit of programming and doing a little bit of logical processing to transform one value to another value.
So they're not installed implementation.
Right. Well, I don't know what you call your security level. Or you call it a security clearance level. I call it a security access level. And yours got, I got red, green, and blue. You have 1, 2, and 3, and then Anthony has, high, medium, and low. And we're all on,
So you're doing.
all Active Directories are different.
You're doing this on a case-by-case basis.
Yes. Yeah. We might have to do this.
Whatever business.
Exactly. Whatever the business is. Exactly. Anthony?
It might be, I don't know, tell me if it might be a good way to understand it, because these two systems are disparate.
Very.
There's no schema masters, as a
Yeah.
result,
Yeah, there's no,
the tables and the records in the database don't match. As a
exactly.
result, you have to translate
You might have to
from one
translate.
database to another, that's why you.
Right. I mean, if we're an easy environment, right? We're both using Active Directory with standard schema. Every user account has a department attribute, and if that's what we're using, that's pretty fine, right? But if you're not using Active Directory at all, what's your claim provider do for a user? Does it have a department? May not have that at all. It may have something completely different, called something else. And then, of course, the values may be different as well, which we can calculate.
Even if you both have Active Directory, if one has like an extended schema, they install a bunch of other things
Right.
onto it, then you still need to translate it.
I still need to translate or calculate a value based upon what they supply. So we need to, we want to keep each organization very, very separate in what they're doing individually, but yet have them work together. So sometimes we need to do those translations. So it's like the organizations might talk two separate languages, and this becomes the translator between them.
So as a business, all your affiliates in this particular function, AEMS, you'll have an entire
Right, claims and stuff like that that they can make. Exactly. So you can have two organizations that might be very similar, just have some small differences. Two organizations have vastly different differences. All right. So if you imagine you are setting up a website and you're trusting Google to authenticate your user and make claims, you'll have to look at Google's documentation and say, well, when a user authenticates to you, Google, what information do you have about the user? His location? Do you have a URL pointing to his YouTube channel? I mean, what information do you contain? And based upon that, I may consume that directly. I might say that what you supply is good. I could just consume it directly, or I need to transform it or calculate something else or what have you to know more about the user for my system. Right, Anthony?
Maybe a simple example would be like on one company database, they store the first name value as under this column called F name. But then on the federated site, they don't use that name. They say their column is first name. So as a result, the computer would never be able to reconcile that.
Yeah.
I understand that. My question was, who exactly initiates this whole program process? Does your system administrator come
Yes.
up and tell you, listen, we're going to be affiliated with Johnson.com. I want you to go into AFS and set
Exactly.
up, configure some claim rules. That's the question.
Yes.
That's exactly.
Right. Yes, this is exactly what's going to happen,
Tells
right?
you to do
Management decides to do this, and then they pass the job off to somebody, a system administrator like us. We're then going to go and figure out what the claim should be, what they supply, what's in their attribute stores, and what rules need to be created to make them match up. Abel?
Reconcile it both ways. So each organization in the
Could be.
FS has to do this.
It could be, yes.
Have to do
Remember,
this.
trust can be one way, though,
Right, that's true.
right? So, but most of the times we're going to configure it true way, and we'll have to reconcile in both directions. It's not usually an easy project, right? It's not something we just whip up and, give me 20 minutes. It's a very carefully planned process that, could take a week or two to get going. And probably the hardest thing to set up is actually using the test environment for this. Because you're going to need a copy of like your production and their production environments and test them out that way. It could be, that's the difficult part. Abel?
If you get something wrong in the translation, the reconciling of the two different
Systems. Yeah.
then does it fail to work at all, or do you start getting very bad errors that mess things up?
Well, usually if I don't have the proper claim, I can't access the resource. So it would fail. Access denied messages. That's one problem. The other problem is the opposite. Suddenly I'm realizing that thousands of users can access websites or services that they shouldn't be allowed to access. That's the scary part. I can deal with a user who should be able to get to the resource, not being able to get it, calling help desk, we'll fix that. But I might not know, unless I'm carefully auditing and testing, that while those users shouldn't be able to get to the employee payroll file, but they're all looking at it now. And I find out because everybody's emailing who's getting paid what in my organization. Or did you hear that so-and-so just went and had surgery? And that's suddenly passing around my organization. And somebody's going, I didn't want anybody to know that I just had surgery. Well, how did it get out there? Well, you can find out problems that way, which is never a good thing. All right, so let's get back on track. Claim provider trust. All right, configured on the relying party federation server. This identifies the claim provider. Right, configure the claim rules for the claims provider as well. In a single organization, a claim provider trust called Active Directory defines how ADDS user credentials are processed, but additional claim provider trusts can be configured. If you have a single organization with two different systems, you can configure that. You might be a single organization. You might have multiple Active Directory forests for some reason, because it may be a merger. That might be a reason you might configure these additional trusts. Second. All right, relaying party trust. They're configured on the claims provider federation service and identify the relaying party. You configure rules then for this party. This is the part that defines the connection to the apps. They're my web services or whatever I'm running internally. And of course, additional party trusts can be configured if necessary. So this is something that the administrator needs to do, is configure these trusts. All right. Trust between federation and the resource, trust between federation and the claims provider like Active Directory. Authentication policies, we like policies. These are methods can be configured for the intranet or extranet, such as whether or not we're using Windows authentication must be used, or we can use forms-based authentication, which is a website thing, where you authenticate to a certain website, a username and password, or are we using certificates, digital certificates to authenticate? Some users may have one policy, others you might have others. This is new in 2012, I think, is the ability to scope these policies. So if you're in a certain group, you'll have to use Windows authentication. Other groups, you'll have to use certificates, and that type of stuff can now be set up. We can also use our good friend multi-factor authentication. You've probably seen this in the real world some places. You sign up maybe for a new YouTube channel. You might say, well, you know what we got to do? We got to send you a text message, and we're going to send you a code, and then you have to, on your cell phone, type in the code that we send you. Make sure that you do have a cell phone, that you are a real live user, all that type of stuff. Right? So there's just some additional thing that we're doing, which might be a certificate, or we need to verify your account to exist on Google or something like that, or a one-time use password is given to you or something. Phone calls, mobile apps might also use this as well. Windows, Azure, multi-factor authentication, a cloud-based service Microsoft makes available to you. So this is really nice. If you wanted to set this up in your organization, it's a service that you can get from Microsoft's cloud. And it will do stuff like make phone calls for you. Or, I don't know if anybody really gets a phone call. Today we use text messages mostly, right? Send that code. Kind of cool. All right, so there's two exercises. We're coming back to this. We're going to give you some time to do exercises 1 and 2. Install and configure Federation services. Pretty straightforward, actually. And configure an internal application to be used by Federation services. All right. So London DC1, Client 1 and Server 1 are used. Only about 30 minutes, and then we're going to talk about deploying it in a business-to-business scenario, a little bit different. And we'll set up some other stuff we'll talk about, like work folders. We'll come back to work folders. It's like weird that it's in here, but they separated work folders in several different places throughout 3 different courses. It's weird. I'm going to fix that in the future. Anyway, so do a Lab A, and we'll resume probably in about 45 minutes because I want you to still take a break. So somebody will hit the lights. I will pause the recording.